Hi everyone and welcome to this video. So my name is Nico Meisenzahl and I would like to introduce you to policy governance management for Kubernetes. Yeah, as I already said, my name is Nico Meisenzahl. I'm a senior cloud and DevOps consultant at Weigdag. We are a Germany-based company. I'm a Microsoft MVP. I'm a GitLab hero, Docker community leader, and I'm working around topics like Kubernetes, containerization, DevOps, and cloud. Yeah, as already mentioned, I would like to introduce you to Kubernetes policy and governance topics. So briefly agenda for this video today. First of all, I would like to talk about cloud governance in general. So why do we need cloud governance? What are the pros? What are the cons? And then doing a deep dive into governance for Kubernetes. Why we need it, and then afterwards how it works. And the whole talk will be based on Open Policy Agent. So I will briefly introduce you to the policy agent itself, and then heading over to the Kubernetes integration, which is called Open Policy Agent Gatekeeper. Then after the brief introduction, we will deep dive into Open Policy Agent Gatekeeper, and I will show you some live demos how these things work. So first of all, cloud governance in general. So what is cloud governance? Cloud governance is used to provide a set of rules that define guidelines that then can either be enforced or audited. So it's basically cloud governance is used to define a scope within a developer, operations guy, a technical person can create and manage his cloud resources in. So it's just to somehow define the regards for someone who's working with cloud governance. And this then can either be enforced. So a request creating a resource which does not match or is not conform with our governance is then be denied and can't be created. On one side, on the other side, it can also just be used to audit. So those resources can be created or are already created, and we just want to audit them to get insights, which resources we are using, how they are configured, are they conform with our security policies, and so on. So cloud governance and policies does not mean that we need to enforce them. Auditing is also a possible scenario for this case. So, but why do we need cloud governance? So in a cloud ecosystem, decisions are made in a rapid pace and are also made decentralized. So it's not as it was years ago, where we have a centralized department in our company which decided so things like, okay, we're implementing a new software, we need a new environment, and we need to follow those security guides which were defined and defined by those centralized departments. But at the moment, we have a developer team or somehow operations team who need to build something for the business and need to get an environment pretty fast and pretty quickly. So deciding those important definitions and guidelines and policies in a centralized manner would really slow down the whole team. And this is why so things need to decide decentralized and also decide pretty fast. And this is where cloud governance and policies can help us. So they allow us to create and manage our resources on our own, but also make sure that those are defined in a way I would like to have them. So security-wise, cost-wise, and so on. So why is it important? First of all, we need to reduce risk. As I already mentioned, things like security, etc. There need to be certain security policies in place, and we need to make sure that those are really met. This is what we can do with risk governance. We can also control our shadow IT if we would like to, or we can at least audit our shadow IT to know which cloud resources our teams are using, and then maybe talk to them, or maybe also build policies for those resources because they're pretty sure that they're needed. And then, of course, you can make it easier for your development and operations team to use and create cloud resources. So just think about you're defining some settings, some security settings, and so on, which are in place all the time, then the developer or the operation team do not need to focus on, okay, which security settings we are needing, rethinking all the thing, implementing all the security issues. So it's just they creating the resources, and your governance policy make sure that the security is met out of the box without them thinking about it. And with this in place, it also helps us to reduce the effort of creating and management those kinds of cloud resources. So this for cloud governance and commons. So let's talk about how Kubernetes governance can help us. So Kubernetes itself brings us a pretty nice and granular authorization using the robust access control called ABAC. And with this in place, we can exactly define which identities or which person, which DevOps guy is allowed to do what with which resources in our Kubernetes cluster. So we can very granular define that the dev A is allowed to create deployments in a certain namespace on a certain cluster. But this in place allows us to control who is allowed to create or manage resources, but we cannot define the resources itself. So we cannot define out of the box that a certain deployment needs to meet certain criteria or definitions. So let's say we do not allow any containers from an untrusted registry or things like this. Now, there are specific things we would like to enforce or audit on a specification level of our resources, which is not possible out of the box with Kubernetes at all. Yeah, some examples. I already mentioned the first one. We might want to use a whitelist to just allow trusted container registries or maybe certain image or text. So if we're thinking about a production environment, we maybe want to make sure that not every tag is deployable on our production cluster. We might want to make sure that certain security settings are set. So that's thinking about not allowing root containers or just allowing a certain user or group and stuff like this. On the other hand, we maybe also want to make sure that certain labels are set for our resources to be able to group them and search for them. In bigger environments, we might want to make sure that the include host definition is not conflicting each other, that we don't use two equal host names and stuff like this. Or in a public cloud environment, we maybe just want to make sure that the load balancer service is not exposed publicly with the public IP, that it's only exposed internally in our internal virtual network in our cloud environment. Just some examples. There's pretty more, just to give you some examples where governance and policy for Kubernetes could help us. Okay, so I already said that it's not possible out of the box with Kubernetes. There's where Open Policy Agent comes into place. Open Policy Agent itself describes as policy-based control for cloud-native environments. It's an open source project started by the company Styra, and it's somehow a unified toolset and framework which can help you to manage and enforce or audit your policies and governance topics. The policies itself are described in a declarative policy language. I will have some slides on this later. And Open Policy Agent is completely decoupled. What does this mean? You can either use Open Policy Agent and include it in your application as a Golang library, or you can run Open Policy Agent site next to your application using the sidecar pattern and a containerized world, or as a daemon on your operating system. And then just talk to Open Policy Agent via REST API to verify and enforce your policies. So Open Policy Agent is not just limited to Kubernetes. It's cloud native tool, can be used with different solutions and projects. So Kubernetes is one example, but it can also be used to authorize your APIs or your applications to verify if a certain user is allowed to do a certain action. You can integrate it with your CI/CD pipeline to make sure that a certain change is allowed to get deployed to a certain environment. You can integrate it with your service mesh to decide which service is allowed to talk to other service. You can integrate it into your SHA, into a Linux configuration, and enforce certain policies. So different solutions. There's a really, really big ecosystem around it. Yeah, some more examples. I already mentioned API and service authorization can be integrated with, example, Envoy, Kong, or Traffic. You can do authorization policies for SQL, Kafka, container network security with, for example, Istio. For CI/CD, for example, you can verify Terraform changes and test them if they are allowed to go into a certain environment. You can do policy management for SSH and sudo on your Linux environments. And of course, also policy governance for Kubernetes, which we are talking about today. And there are many, many more. I included you a link to the list of all supported tools and integrations. So, but how does OPA, Open Policy Agent, actually works? So, as I mentioned, it's decoupled. So we have we have our service. So let me just enable my laser. So we have our service, and we have somehow a request coming in, and we would like to verify if this request is allowed to do certain stuff. So then we define our service and tell the service to send any kind of query, which is just JSON data, to the Open Policy Agent, and then Open Policy Agent will use the policies defined and additional data if needed to decide whether this request is allowed or should be denied. And this information, if it's allowed or denied, so the decision is then provided back to our service using JSON. So with this in place, we do not think about policy and policy management in our application. We just need to talk to OPA, providing the input information, providing the policies upfront, and then OPA will decide for a decision and will tell us whether it's okay or not. So just an example with some little bit more data, a little bit more deep dive. So let's say we have an API and we have a post call to /API from an authorized user. In this case, it's just Nico. So our application will then JSON with the method, the path, and the user to Open Policy Agent, and then Open Policy Agent will use its policies to decide whether Nico is allowed to post to the API or is not allowed to post to the API. There would be the option to inject the data we sent to OPA with more data provided by OPA. So this is for, let's say, more advanced policies where you don't just need the information from the service, but also need some other information in place. Then you can provide the information up front, and then you can use OPA, or OPA can use both informations, the actual data and the input to verify the request. And then after he verifies the request, the OPA just sends back the information, whether it's allowed or the request should be denied. And with that, our application can then either accept the post request or deny it. So, but how do we define those policies? Now, we are doing it with a language called Rego. Rego is the language we are writing OPA policies in. It's inspired by Datalog and we extended with some support for JSON. It's a declarative policy language. I already mentioned that one, though we're really writing declarative or policies, and OPA will then decide the action based on it. So an example in the case from slide before, we would just define or ask us where Nico is allowed to post a payload to /API. On the right side, we're doing an example for this. So we're defining a package name. We define the default action, which should be false in our case, and then we decide when to allow the request. In this case, it's based on two definitions. It's either is a request a post command. On the other hand, is an input user Nico. Of course, this is hard-coded, but just should be an easy example. And if both of those are met, the response from OPA will be allow the request. So to get started, there's also a nice background from OPA. So it's a HTML5 based portal which you can use to build your queries, test your queries, provide some input data, and so on. So it's pretty nice. And I also linked some Rego deep dive slides on SlideShare, which might have you to get more details into how Rego works. So we finally, the big picture, once again, we have our request, our post request, we have our input data, and now we also here have our policy definition in place. Once again, I already talked that default action is false, and then we allow based on if it's a post command and if it's the user's an owner, in this case it's hardcode Nico. We do not need any input data, further input data, and then OPA will allow the request because it's a post and the user is Nico. Well, this is how OPA and Rego works. So some tips. You can also use run OPA as a binary. So with OPA run and OPA test, you can locally test and verify your policies and your definitions. There's a VS Code plugin which can help you to get started. And there are also some kind of APIs. We have the bundle API, which allows you to either send policies to OPA and also to send data. So with the additional input data to OPA. We have a status API, which we can use for observability and monitoring purposes. I will have a short demo on this later. And we also have the log API, which we can use to receive audit logs. So if we don't permit things, we just want to audit things, we can use the log API to collect the logs for the audits and then put it into our logging analytics observability tooling. Okay, so this is the basic of Open Policy Agent itself. But now we are talking about Kubernetes, so we need to talk about OPA Gatekeeper, which is the Kubernetes implementation of OPA. So OPA Gatekeeper is also open sourced and is built by Google, Microsoft, Red Hat, and Styra together. It's based on the Open Policy Agent itself, which is running as a daemon, containerized deployment on our Kubernetes cluster. It brings the Kubernetes admission controller and custom resource definitions. So custom resource definitions are used to either define configurations for OPA itself, as well as define our policies and templates policies. And then we also have an authorization webhook in place, which allows us to inject our policies and deny a creation of a resource if the policy is not met. But I will go into detail later. And the installation is pretty easy. So the Gatekeeper provides Gatekeeper project provides a Helm chart which you can use to install, or just doing a kubectl apply. You'll find more details in the link below. So yeah, how does it work? So I already mentioned we have the Gatekeeper daemon running in our Kubernetes cluster and a container. And then we have our admission controller and our webhook, which are then query against our OPA daemon to make sure that the policy is met, if a request needs to deny, and so on. And we have our custom resource definitions, which we can use to configure OPA and to also define our policies and our policy templates, which then get injected into our OPA runtime. And of course, OPA can also watch to the API server to get additional input data. So we can define that OPA synchronizes or replicates some kind of resources from our Kubernetes cluster to do source advanced searching. So with this in place, we can then inject additional data, which I showed you before, because OPA is aware of this data and replicated this data upfront. So we can decide, okay, we would like to get all pod definitions, pod resources, we would like to get all inquest definitions and so on. And then we can build advanced policies based on this data. yeah, after we install, what do we get? We get two deployments running. First one is a Gatekeeper audit, which is used for auditing purposes. Then we have the admission controller listening on the custom resource definitions we have here. First of all, the config, which is used to configure OPA, like doing stuff like we would like to replicate data and stuff like this. And then we have some constraints templates, which we use to build our policies and define our policies. And I will have a demo on this later. And then last but not least, we have the authorization webhook, which allows us to inject into the creation of resources to make sure that we can stop the creation upfront if they are not conform to our policies. Okay, so with this, I would like to shift to our demos and show you some stuff in action. Okay. So here I have a Kubernetes cluster based on kind. Just created it some minutes before. It's pretty empty so far. Just installed Prometheus, which I will use to show you the auditing later. But first of all, let's start with installing OPA. Created some installation script. So let's have a short look. The installation creates a namespace for Gatekeeper. It's created the custom resource definitions for our configurations. Then if we go to the next step, it's defined the custom resource definitions for our templates and our constraints we need to define to get our policies working. Then we getting a service account, we get some roles and cluster role bindings. We're getting our secrets, and then we're getting our deployment for the Gatekeeper auditing, as well as a deployment for our controller manager. Yeah, last but not least, our webhook configuration, which just injects into the creation of resources and make sure that the policies are met. Yeah, with this in place, just install it. So kubectl apply -f deploy OPA. Let's then have just to wait to get everything started. Of course, some different namespace. Okay. Need some more time, but we should be fine now. Okay, so let's have a look at our first example. Let's say we would like to have required labels in our environment to make sure that all resources have required labels. So have a look in our definition file. And here's where we start defining our policies. So first of all, we defining a constraint template, which is one of the custom resource definitions we just created, giving it the name, providing some properties and some information we will then later fill the template with. We need to define a target. This is our admission controller, and then we have our Rego part we need to implement. Now here's the actual policy we're defining. In this case, it's a pretty small one. So we're just providing the input labels from the resources we are creating and verify whether those labels we would like to define are part of the definition of the resource definition or not part of the resource definition. If they're not part of the resource definition, we will deny the creation of the resources and just put out a message with some information that we need to provide some labels. And below, we then creating a registry a policy out of the template we created above and just telling when to use this template and which resources we would like to use the template. So first of all, we're telling it, okay, we only like to run this this policy rule for namespaces. So only namespaces need to have a certain label, and we would like to have the label N for environment to be part of the definition. So if we now apply this one, okay, the template was created. Because the template itself also creates a custom resource definition, we get an issue, but after the second run should be fine. So now it's also created. So we have now our policy in place. And if we now create, you can have a look at our my demo file. If we now create namespaces, and I have two examples, we have just a namespace without any kind of labels, and then we have a namespace with labels, environment test in place. And if we now apply the two namespaces, the first namespace or the namespace with the label gets created. And then the namespace without the label, we get an error message. And it says us, okay, it's denied because you must provide a label environment. So if we now check for the namespaces, we also see that only one namespace has got created. So we reject the namespace without the label. Okay, so let's have a look at the second example. Maybe we would like to validate our source images. So we once again define a template and then map the templates to certain informations. So in this case, we are checking the container image. We're doing for the container itself, but also for the init container. So we are verifying the init container as well, any container or sidecar containers with this in place. If it's once again not met, we're once again just printing an error message and denying the hold request. This template we are then mapping to be sure that it's running on kind pods. So only would like to deny pods with this configuration. We only want to deny pods in the namespace default, and we only allow certain images. So in this example, we are allowing our GitHub repo registry. We are allowing a certain registry on our Azure cloud, and on Docker Hub, everything which is part of our organization ByteDuck. So let's once again apply this one. Validating image sources. Once again, we do it twice. So everything is created. And if we now have a look on our demo, it's exactly the same. We have, first of all, a deployment based on Nginx. So we're using the Nginx image from Docker Hub, which should be denied. And in the second example, we have a deployment based on an image from our organization from Docker Hub, which should be fine. So let's apply this one. So once again, we are not seeing an issue. We're seeing that both deployments got created. So let's check for the deployments. We have our app running on our trusted image, which is up. It's not yet ready, but it started. And we have our Nginx deployment, which is not running, and there's no container scheduled, no pod scheduled. So let's have a look at the pods, and we see our app is already running, and we see no pod definition for our deployment. So the deployment was created, also the replica set got created, but because we checked this one on a pod level, the pod creation got denied. So if we check for the events in this namespace, yeah, we should see the arrow. Our mission controller denied the creation because the container Nginx is not part of our allowed images or allowed repositories. So once again, we denied the pod from being created. So last but not least, another example, with this one, we would like to enforce that inclusive definition host is not conflicting. So this will not have double configurations here. So for this, which is a bit more advanced configuration, we first of all need to tell Gatekeeper to synchronize or replicate certain informations. Because if we're checking our policies, we only have our inclusive definitions. But to verify if there's collidating inclusive definitions, we need to make sure that those inclusive definitions are also available to be checked by OPA. So with this, we first need a configuration with a name configuration in the namespace of Gatekeeper and telling them to synchronize inclusive definitions. In this case, we sync the old API as well as the new API just to make sure. So we're telling OPA to replicate all inclusive informations. And then once again, we are creating a template with our Rego definition, where we're validating whether there's a conflicting inclusive host, and if so, we are once again output a message information. And then we are mapping this template to both API groups and our inclusive resource. So let's apply this one. And here it is. Once again, we have a demo for this. So we have two inclusive definitions, my inclusive, which has a host called my-app whiteduck.de, and we have inclusive definition, which means duplicate inclusive, which is the same host, but then redirecting to a completely different path and completely different app. So this one would not be really good to get it to production. No, in this example, we should make sure that only one inclusive is created and the second one is denied. So let's have a look. We're creating this definition, and once again, we're seeing that the my inclusive gets created, and the duplicate inclusive gets denied because it conflicts because the my-app whiteduck.de is already used. So with this in place, you can build certain Rego policies to deny certain requests if you would like to. But we maybe also want to audit our informations. So with this, we can maybe go for the unique host. So we can do get informations about one of our policy templates, and then grab our the policy definition. In this case, our enforcement. Output the YAML, and you will see that you also get some status information for auditing. So in this example, in the status, we do not have any violations because we already denied the request, but we would see informations which resources are not met our policies, and then could audit them, decide what to do with them on one hand. On the other hand, as I already mentioned, OPA Gatekeeper or Gatekeeper also provides some endpoints. So we can also use Prometheus to gather those metrics and then build nice dashboards or alerting based on it. So let's have a look at this. I'm just having a local Prometheus instance running. So just jump over, just did a port forward. New empty instance, and if we now check for Gatekeeper, we see certain Gatekeeper information we can use. And there we have maybe things like Gatekeeper constraint template, ingest count, where we get, okay, we have a constraint for a template, and maybe execute it. And there we're thinking, okay, Here we have our metrics data and can then use this for building dashboards with Grafana, doing metrics based on them, alerting based on them, to use to audit our environments. So it's a pretty nice feature. Okay, so with this, just some smaller demos how this all works. You find my slides for this on my slideshare account. All the demos are also available on my GitLab account, so you can just play with them, test with them, customize them, and just ping me on Twitter or via email if you have any questions. Yeah, thanks for joining.